In this particular quiz, we're going to be applying concepts of one variable statistics to a data set. This data set is taken from an analog ruler, and we look at the data set over here. We can see that there are 5 trials, and then the many one variable statistics we would calculate. So our first instruction is to fill in the 4 row headings for the first 2 columns. So when we look over here like so, what do we have? Well, we have, in this case here, we have a length in centimeters. And we would have, in this particular case here, a reading error. If it's lined up on the ruler at both ends, the reading error, this goes by the tenths, so it would be to the hundredths place. So the reading error would be plus or minus 0.05. Now, if the object were lined up, we are lining up at this end and at this end, so that that error might be twice as large, and we call that the total estimated error, and that would be plus or minus 0.10. And then in this, we might label this the trial number. 1, 2, 3, 4, 5. So those are the typical headings we would have for one-sided variable data. So the next series of questions, 5 through 18, is to compute and record the mean. Now, we have a powerful tool at our disposal, of course, in spreadsheets, but in a testing situation, we only have a graphing calculator. So what we would do next is open this, we would enter this data into our graphing calculator. So we're setting about a new project here and analyzing the data on the quiz. The first thing we want to do is to clear our lists, make sure our lists are cleared out. Second plus is memory. Choice 4 is clear all lists. Clear all lists, like so. And I can even clear the screen. And now I go to statistics. Since we're dealing with statistics, we're going to edit statistics, which is choice 1. And now we're going to simply enter the data from the quiz. 2.44, 2.43, 2.45, 2.44, and 2.46. So I've entered it. I want to just make sure that it's correct. I double check it against my list. And sure enough, that's correct. Our next step is to calculate some statistics on this data. And so statistics is the stat button. And calculate. And we want to calculate the one variable statistics. So we hit enter. It has selected list 1, and it just so happens that that's where our data is. We will arrow down to calculate, and we will hit enter. And it will calculate all of these statistics for us. We can see the mean and the sum and the standard deviation and min. And if we arrow down, we can find the max. So at this point, we just start writing in the values with the proper significant digits into our quiz. And so the first question is the mean. Our data went to the hundredths place, so we'll report 2.44. The maximum value, when we scroll down, happens to be 2.46. The min value, 2.43, I record that. And now we're going to calculate the range. Now, we want to always work with unrounded numbers. So the way we can do this is go to the home screen, and we can use the vars function. So vars, what we want is some of the statistics that were just calculated. Whenever you perform one variable statistics, those numbers are dumped into and assigned a variable stored under statistics. Select 5, you can see there's max and min. So if I choose max minus vars statistics min, that's going to give me the range, 0.03. Now I may want that again, so I'm going to store it. So I'm going to store that as R. And R is right there, so I hit alpha R, enter. And now whenever I press R, I can get that value. The next thing we want to calculate is so we entered the range. The next thing is the absolute uncertainty. The absolute uncertainty is the range divided by 2. So we can now say alpha R divided by 2. And that gives us an absolute uncertainty of 0.015. Now 0.015, our data is in the hundredths place, so this 5 would cause us to round up to 0.02. For the right significant digits, we'd record 0.02. However, in the future, we may want to work with this, so we want to store this. And since this is the absolute uncertainty, maybe we would store it as A. So store alpha math, which is A. And so now we've stored that unrounded value. So the upper limit in this case is going to be the mean plus the absolute uncertainty. So the mean is already stored as vars. That's number 2. So the mean plus alpha A, the absolute uncertainty, and we get 2.459. Now notice that this 9, because we kept it unrounded, would cause this to go up to 6. So the upper limit then is 2.46. Now here's a simple little trick to save ourselves a little work. We can do second entry, so we don't have to type this over again. Will save us some work. And we then can just change the plus to a minus, and then we hit enter, and we get 2.429. The 9 causes that to round to a 3, so we get 2.43 for our lower limit. Now the standard deviation, we can just pull that up by selecting it, 3, and that's 0.011. Now that's automatically stored, but we only want to record to the hundredths place, and this second one doesn't allow for rounding, so the standard deviation is 0.01. The data error, however, is 2 times the standard deviation. So 2 times vars statistics SX is 0.022, so still not enough. So the data error is 0.02. Now the upper limit in this case is going to be the mean, plus 2 times the standard deviation, Sx. So we get 2.466, so that means this 6 will cause this 6 to round up, so we get 2.47. And that trick that we just used, second entry, and we can change the plus to a minus. Oops. This one is the minus. I'll go back and put my mean in there. Gives us 2.42. There's no rounding here, so 2.42. Now the percent data error is based off the data error itself. So the percent data error is the data error divided by the mean times 100. Well, the data error is 2 times the standard deviation. So I could do this trick again, second entry, and I'll just back up, delete these 2, and now I've got 2 times the standard deviation divided by the mean times 100. And so we get 0.93, and that 3 is not large enough to make it round. So the percent data error is 0.93%.